Hello, this is Mr. Wynn, and this video is over area part 2. We're going over area of regular polygons, composite shapes, and shaded area. So remember that a regular polygon is a shape where all sides are equal and all angles are equal. It's the same. We generally associate regular in shapes with 5 or more sides, but people forget that squares and equilateral triangles also count as regular polygons. The area form for any regular polygon is area equals 1/2 a times p, or you can say a times p all over 2, where a stands for apothegm and p stands for perimeter. The apothegm is the line from the center of a polygon to the midpoint of any side on that polygon. The line and the side are always perpendicular, making a 90-degree angle, and depending on the shape, it is sometimes half the height, but not always. Alright, so squares actually have 2 area formulas. We're going to try both formulas and see if they match. So here's a square, every side's 10 inches. So let's do the original formula. So y'all know area equals length times width, or base times height. So that's 10 times 10. In this case, area is 100 inches squared. What about this new formula? It says area equals a times p over 2. If I fill that in, the apothegm is the middle of the shape to the midpoint of one of the sides. So because this is actually parallel to the other side, this is actually 5, half of that. So my apothegm is 5. My perimeter, 10 plus 10 plus 10 plus 10, or 10 times 4 is 40, all over 2. So then that gives me 200 over 2, which is 100 inches squared. Same answer. So this formula works. All right, so now we're going to try the harder shapes. So on the left, we're going to find the area of that regular pentagon, because there's 5 sides. So remember, always write the formula. Area equals a times p over 2. Fill it out. A they gave us is 7. 7 times p perimeter, 12 times 5, that is 60 over 2. That is 420 over 2, which is 210. No units here, so unit squared. All right, here's another one. It is a regular hexagon. So again, write the formula. Area equals apothegm times perimeter over 2. Now be careful, we do not have the apothegm here. It is not 10. 10 does not go from the center to the midpoint of a side. 10 goes center to one of the vertices. So we need to actually find the center to the midpoint. Let's go right here. This right here is the apothegm. This is a right triangle. If that side's 12, the whole side's 12, half that's 6 and 6, where's the midpoint? So we have a 6 blank 10 right triangle. You can do Pythagorean theorem, or you can memorize your triples. This is a 6, 8, 10 right triangle. So the apothegm here is actually 8. So 8 times perimeter, 12 times 6, that is 72 over 2. Then I calculate that. 8 times that number, that is 576 over 2. Then when I divide by 2, I get 288. Units are not given, so I'll say unit squared. Alright, like the previous area problems, we can work backwards. They might give you a word problem. If the area of a regular decagon is 100 meters squared and the length is of one side is 5, what's the length of the apothegm? You can draw the picture, you don't have to. Just write the formula and fill it out and solve correctly. They give us a 100 meters squared, so 100 goes here. The apothegm is missing. The perimeter, they gave us one side is 5, but this is a regular shape. That means all the sides are 5. So there's 10 sides, and all of them are 5. 10 times 5 is 50. The perimeter is 50 over 2. I can get rid of the fraction by multiplying both sides by 2 to get 200 equals a times 50 is 50a. Divide both sides by 50, you get 4 equals a. So my apothegm is 4 meters. Alright, next problem. Alright, the hardest regular polygon questions are when you need to find the apothegm using just the side measures. This combines knowing how to find the interior or exterior angles of a polygon, making a right triangle, and then using trigonometry. Alright, so find the area of the regular hexagon that has a side length of 10 meters. Round your final answer to the nearest hundredths place. So usually they don't give you a picture, but I drew a picture for us. So first, we need to figure out the interior angles. So to find the interior angles, you have the formula 180 n minus 2 over n. So 180, 6 minus 2 over 6 will be 120. So all these inside angles are 120 if you want that. One other option you could do is find the exterior angle. So 360 over n to get 60, and then do a linear pair. So you could have found 60 here. Let me use a different color. I could have done 60 here, and then done a linear pair at 120. Alright, so, but then you have to cut this angle in half. So now I'm going to cut this angle in half, so half of 120 makes 60. Here's my right triangle I'm making. If I really wanted further, I could do a 180 minus 6 minus 9 makes this 30. But there's the little right triangle we have. And remember that the sides are cut in half. The right, so this is 5 and this is 5. So we have this right triangle where the bottom's 5. We have 60 and 30. And we're trying to find this little thing right here. Now, I usually do a different formula. I like doing a 360 over 2n to find that top angle directly. So I did 360 divided 2 times 6. I got that 30-degree angle. I usually don't like using that bottom right angle in the triangle, but it does not matter. So now we have this right triangle, again, where the bottom's 5. A is missing. We have 60 degrees, 30 degrees. You can use special right triangles, the 30, 60, 90 pattern, x, x, 3, 2x. But I use trigonometry. So let's say you start at here, at 60. I have H, A, O. I'm not using that. So I'm using SO, CA, or TOA. We're using TOA. Fill it in. Tangent of the angle. Tangent of 60 degrees equals A over A. So it's apothem over 5. Multiply both sides by 5 to get rid of the denominator fraction. A is by itself. That's good. Type in the calculator. We get this. And I write right here. Make sure your calculator's in degrees. Now we have the apothem. Now we can finally do the original formula. A equals A times P over 2. We know that A is 8.66. Perimeter, 10 times 6 is 60. And over 2, type in calculator, you get this, 259.8 meters squared. And there's that in the calculator. All right, next, we have composite figures. Composite figures or shapes are just multiple shapes put together to find the area of a composite figure, find the area of each shape, and add them all together. Be careful of half circles and semicircles and quarter circles. All right, note 1, you're allowed to cut up the composite shape into as many pieces as you want. And note 2, there's an adding method, which I recommend and which I'm going to teach y'all, and a subtracting method, which I will not go over. We could do a live session over it. But here's a shape, find the area of this giant thing. Notice the top has a semicircle, half circle. So we're going to do the circle formula. Area of a circle, all right, this equals a pi r squared, but then I'm going to divide by 2. So do we know the radius here? The answer is yes, we know it's 4. So it's going to be pi times 4 squared. So that is 16 pi. And I'm just going to make that a decimal. Let's see, if I type in the calculator, I get 25.13. That is not the answer. That is 50.26. Now I'm going to divide by 2 because it's a half circle. So I get 25.13. That's where that came from. All right, no units. All right, we found the semicircle. Now we're going to find this, that's a trapezoid. All right, do we know the base? We know the bottom's 40. Do we know the top? Answer is yes. That's part of that semicircle. The radius is 4. That means this is 4 and this 4. So together that's 8. So area of the trapezoid. That is base 1 plus base 2 times height over 2. So make sure you know your area formulas. Fill it in. That is 40 plus 8 times the height is 10 over 2. That is, let me keep going down. That's 48 times 10 over 2. That is 480 over 2, which gives me 240 units squared. So we found the trapezoid. Next, let's try to find this rectangle. So I'll go down here. Area of the rectangle equals base times height. That's easy. You fill it in. So its base is 40, height's 20. Multiply together, you get 800 units squared. And last, we have this triangle over here. We have the height, which is 20. When the base, we know it's 20 over here because this goes over there. That's a rectangle. So we know base of 20, height of 20. So let me do it right here. So area of the triangle goes base times height over 2. I'll just go sideways. Base is 20, height is 20 over 2. That is a 400 over 2, which is 200 units squared. I'm at all those numbers up together. So we have the semicircle plus the trapezoid plus the rectangle plus the triangle, and together that makes 1305.13. 1305.13. No units given, so units squared. So that's a pretty complicated problem. Now I had some other options. Some people don't like trapezoids. They might make this a rectangle and a triangle, and that's fine. You could do that. You could also do 2 triangles here instead of 1 like I did. You do this top one and this bottom one. You would have to split that 20 into 10 and 10. Let's see, you'd have to know this is 8, this is 8, and that's 40. I mean, this is 32, and then this is 10. But you could find all those shapes. You can even put this further right here, too, and make more rectangles. Again, you can cut as many shapes as you want. So that means this is 8, and this is 32, and this is 20. But yeah, that's some examples you could do. All right, split the following composite shapes into base shapes. Again, vertical and horizontal lines are the best. So here, trapezoid, we know you need base 1 plus base 2 times height over 2. But some people forget that formula, so they can just make 2 triangles and a rectangle. That works. For this next shape, you could do 2 rectangles if you draw vertical, or you can do 2 rectangles where one is really long and goes sideways. Or you can even do both and have 3 rectangles. You know how much work you want to do. Down here, I could draw a sideways line and have 3 rectangles, and that's it. Or I'll make life harder. I could do I could go vertical to make 3 rectangles like that, or I could make even more rectangles. Up here, let's see, I can draw this, that's a weird shape, I can draw it downwards. Now I have a rectangle and a trapezoid. If you don't like a trapezoid, you can draw a sideways line here to have 2 rectangles and a triangle. That's easier. Down here, you can draw sideways to do a long rectangle and a triangle, or if you go vertical, you can do a rectangle and a trapezoid. If you don't like the trapezoid, you can draw the sideways and do 2 rectangles and a triangle. You have lots of different options. All right, next we have shaded area. Shaded area is just how much a picture is shaded. You can figure this out by finding the area of the entire shape, the whole picture, and subtracting the undesired or unshaded parts. So here we have the big shape. Big shape is a rectangle. So the area is base times height. That is what, 19 times 7. That gives us 70, 140, 133 inches squared. But we don't want this middle inside part here. We can get rid of this little rectangle on the inside. So we're going to find the little rectangle. So that's still base times height in this case. It is 4 times 15. That's 60 inches squared. You subtract the 2 numbers. So 133 minus 60 gives us 73 inches squared is our shaded spot. All right, the shapes don't have to be the same either. So here's another example where they worked out. You could have a square board of 4 circular circles in the middle that's unshaded. So you have a big picture square, base on gets you 100. You have circles, but 4 of them, you get 50.3. You subtract the 2, you get the unshaded area to be 49.7. Because if we try to do this problem, there's no way to find the area of this weird shape right here. So you have to do the whole thing minus the things you don't want. All right, in the last problem, extension of shaded area, geometric probability, think 1 over total. That's what probability is. So what's the chance or probability of throwing a dart randomly and hitting the shaded spot below in each figure? And do note that they can ask you the chance of hitting the shaded or unshaded area. Just pick the correct numerator. So the shapes we just did, remember this is the shaded area, unshaded area, and total area. We do 1 over total. We want it shaded, so we're going to do 73. Total is 133. When you divide that, you get this. We have a 54.88 chance of hitting it. For this weird board of circles, shaded is 49.7, unshaded is 50.3, the total is 100. We want to hit shaded, so it's 49.7 over 100, which is just actually 49.7%. But if you look at the picture, it's actually drawn to scale. You wouldn't think that the unshaded area is bigger than the shaded area, but it actually is. So you have a lower chance of hitting the shaded area than the unshaded area. That's it. We'll do more of these in the live sessions. Thanks for watching. See you soon. Bye.